and hello everyone. Thank you all so much for taking some time out of your afternoon to join us today to talk about the iSeq 100 Run Quality and Best Practices webinar. Let's go ahead and dive right in. Today, I'm hoping we'll be able to achieve two objectives. First, just to kind of provide resources and guidance on navigating iSeq 100 run reviews, some best practices, and navigating some unexpected situations that may occur. After this webinar, I'm hoping that you'll be more comfortable operating the iSeq 100 during those unexpected situations, and more so just kind of in general, have a better idea of what to expect when you're sequencing. And like all good presentations, we do have an agenda today. We'll be touching on instrument setup, run start, run review, and post-run management. So on the instrument setup side of things, here are a few of the topics we'll be covering: first-time run setup, the Illumina Proactive service, the system checks, run output options, and we'll also touch up on setting up network output locations on the instrument as well. So we're starting right at the beginning when the instrument arrives at your doorstep, at your lab step, the first-time setup. When you first unbox and start up your iSeq 100, you'll need to go through that first-time setup. Once the iSeq control software has initialized, you'll be presented with the setup screen. Clicking setup begins the process of getting the instrument ready for sequencing. You'll be performing a system check to confirm instrument performance, and you'll also configure different system settings. During the system check portion, you'll need to insert the test cartridge and test flow cell that came with the iSeq 100, and after that first-time setup completes successfully, the instrument will be ready for sequencing. You'll be presented with the option to sequence from here on out on the instrument itself. We also have some really great information on that first-time setup on page 11 of the iSeq 100 system guide, and also in this really nice iSeq 100 setup poster. I highly recommend checking that out if you haven't already. It has a really nice overview of what to expect in the box, as well as how to kind of set it up. It's really nice, and if you did get those presentations in the PDF form, all of these links here are going to be clickable for you. All right, so moving right along, we just talked about the system checks as a part of setup, and those are really useful for any unexpected situations on the iSeq 100 as well. If there are any situations that come up where you'd like to confirm instrument performance, this is the best way to do that. We'll quickly go over how to set up the system check here. So this is a small screenshot, but really anytime you want to do something outside of starting a run, you'll want to start by clicking on that hamburger menu on the upper left-hand corner of the iSeq control software. There are going to be a lot of items in that dropdown, including the system checks, which we are interested in this moment. After you select the system checks, you'll select all of the tests, the mechanical, thermal, optical, and sensor tests, and then follow the prompts to load the test cartridge and the test flow cell. Just some quick stats on the system checks. It takes about 45 minutes to complete if all of the tests are selected. The reusable test flow cell and test cartridge have 130 uses if you're upgraded to the latest version of the iSeq 100 control software, version 2. If you have a question about which version of control software you have, if you go to step 2 over there, you can see the about. You can just click on that about, and it will tell you which version of the control software your iSeq 100 has. And if there are any failures in those system checks, highly recommend reaching out to Illumina Technical Support, and we can help troubleshoot. A lot of the times the files we'll request are the files that are found in the Illumina iSeq system checks that will have all of the information that we'll need to diagnose where exactly the error occurred. If all the system checks pass, I highly recommend continuing to use the iSeq 100 instrument. Because the fluidics and optics are incorporated into the reagent cartridge and flow cell, all of the components on the iSeq can be tested, and because of the limited number of moving parts on the iSeq 100, the tests are really robust and can capture any instrument issue that could impact sequencing. Another facet of the instrument setup is determining whether to turn on Illumina Proactive support, which helps facilitate troubleshooting and detect potential failures. There are a few really great tools on Illumina Proactive. As a tech support rep myself, I'm really biased on the enhanced service and support side of things, so we'll start there. First up, 25% faster case resolution on connected instruments. Improved customer experience. On this side of things, I can definitely advise, that when that Illumina Proactive is on, it helps, getting to the root of the issue a lot quicker through those phone calls or email conversations. And we also have remote diagnostics and secure data sharing. On that secure data sharing, I do want to highlight that what we're sharing is run metrics and some hardware metrics. You're not actually sending over any DCLs or FASTQs. No sequencing data gets sent over. Even like customized run names don't get sent over to us at Illumina Technical Support. We're only able to review like the standardized run ID. The other part that I wanted to chat about there, just again, it's really helpful for quick run review with the tech support team over the phone. You don't have to send lots of data back and forth by emails or through those secure file transfer links. And we also have alerts that go directly to the TS teams that we can, proactively reach out to assist, such as clustering failures, which we'll discuss later on in this presentation. And on the Mylllumina side of things, there are near real-time run metrics that are reviewable from the Mylllumina account. And I think most importantly and probably most helpfully, historical fleet performance. So you can see how instruments are performing over time in your lab. It's really, really helpful to kind of spot different trends that you might not notice when you're in the lab day to day. Things like it's really easy to notice, one run that has lower Q30 scores than expected, but here you can really see trends over time, which is really, really nice. A lot of really cool tools with Illumina Proactive. And if you or your IT team have any questions about Illumina Proactive support, we have a lot of really great resources, including data and security overview and the Illumina Proactive Tech Note. And if you have any questions about how to utilize these features in Mylllumina, we also have that Mylllumina overview as well. Highly recommend checking that out to see how you can actually, benefit from the run metrics that are sent up. All right, and then moving right along, last note, I just wanted to provide some guidance on how to actually set up Illumina Proactive. Once again, we're using that hamburger menu on the left side, and then this time we're going to select System Settings. And then in the Run Mode tab, you'll select either Manual or Local Run Manager. And then you'll select either one of any of these base-based sequence hub settings, either Run Monitoring and Storage, Run Monitoring Only, or Instrument Performance Data Only, or none. If you are utilizing base-based sequence hub, though, you will be utilizing that Illumina Proactive. And since we've discussed base-based sequence hub a little bit as an option, I also want to take a quick moment to go over the different output options on the iSeq 100. To start, the simplest answer is, we can run in local mode only, just having the instrument saved to itself. We could also have the runs go up to base-based sequence hub if you have an account there, or it can go to a local network location. You could also have it go to both base-based sequence hub and that network location at the same time. As a note, a copy is always saved locally as well in a temp folder, just in case runs output to the network or base-based sequence hub run into any unexpected situations. So, if the network goes down in the middle of a run, don't worry, your run information is still saved locally for that run and will stay saved until we clear it out, which I'll talk about later on in this presentation. And then finally, we have a few services that transfer those files on the Windows computer. The first is Universal Copy Service, or UCS. That's going to help copy both to base-based sequence hub and to the network location, while Local Run Manager, Job Service, and the Analysis Service are only going to help transfer any analysis done by Local Run Manager, such as FASTQs generated, to that network location. So now that we have some idea of the different output options available, I wanted to dive deeper on connecting the iSeq 100 to a network location. The iSeq 100 is not recommended for long-term storage solution, and many customers are on a network, so I wanted to pull together some slides that go over the networking side of things. I know it's only slide 11 of this presentation, and I promise we'll get to some actual iSeq 100 run evaluation in a bit. I myself am much more of a scientist than a networking specialist, but I'm hoping that this information helps you, even just in conversations with your IT team. I know it's been helpful for me on the phones discussing with IT teams to kind of have some of this vernacular. So to that point, we don't have to read every bullet point here, but I did just want to hit some of the highlights here. The first one is that universal naming convention, or the UNC path. We recommend using that over the like a mapped network drive path like the Z drive here. And that's because the Z drive is a relative location where the computer is connecting to the network location, whereas the universal naming convention is kind of like the GPS coordinates. That is going to be a fixed path every time. And should the network get disconnected, the Windows computer prioritizes and has a much easier time reconnecting to the universal naming convention rather than the mapped network path. And so for the Windows 10 computers, we recommend using that UNC path instead of the mapped letter drive, just to help ensure that there's a tighter connection between the instrument and the network location. And again, just because, oftentimes there's a lot of analysis that happens once the run gets over to the network location, and want to make sure that you can use that data as quickly as possible. Step 2 here, making sure that the account that we're using to access that network location has read and write permissions. And it's not a lot of data being generated on the iSeq 100. The max run is generally around 2.5 gigabytes of data, but it is important to make sure that there's enough space for that run on a network location, especially if it's sharing that network location with a couple of different instruments. All right, and then last but not least on the networking side of things, I wanted to go over what it looks like to connect to an instrument and talk through some of the reasoning as well. So by the end of these steps here, ideally, the iSeq 100 would be able to connect to a server and transfer the data successfully. So what you'll want to do first is log into the instrument using the local user account on the iSeq 100 instrument. That's generally the SBS user. And then you'll open File Explorer, which is kind of just like the My Computer on Windows 10. You can also get to File Explorer by searching on the bottom left-hand corner. And then you'll enter that UNC format for the network location into the bar there, almost like you're typing into a web address. And then you're generally going to get prompted to enter network credentials. That is the account and password that has actual access to that network location. Once you enter those credentials there using the domain and username and the password, you'll want to select Remember My Credentials. And it's important to select Remember My Credentials because then we're actually caching those credentials as a part of the SBS user account. So the SBS user account can log in to that network location through the SBS user account. And then once we've done that, we'll need to make edits to several Illumina services to actually make sure that the SBS user Windows account can use those credentials that we just cached. So to do that, we'll need to go to the program services. Similar to how we found File Explorer, you can just search for services in the taskbar and then right-click and run as administrator. Generally, you'll want to enter the local admin credentials, which is going to be SBS admin. And then you'll locate those Illumina services we talked about earlier, the Illumina Local Run Manager Analysis and the Job Service, and Illumina Universal Copy Service. I find it helpful to sort all the services by name and then just start typing ILL. I'd also recommend maybe getting a keyboard from a different computer and plugging it into the iSeq 100 in this instance rather than trying to use the onboard computer keyboard, just because it's a little bit nicer to have an actual keyboard because you're going to be inputting the password a number of times. All right, moving right along to step 5. So then what we'll do is right-click on one of our services. In this case, we're going to follow Local Run Manager Analysis Service. And then we're going to select Properties and navigate to Log On. You can see that highlighted in purple here. It's that next tab. Then we're going to select this account, and then we're going to hit Browse. And the whole point of searching Browse there is that we can find that SBS user and log in as them, or whichever local user credential. If it's going to be another user, I would recommend working with your IT team because it can get a little bit confusing what the different user accounts that are on the instrument are. But generally, it's going to be SBS user. Then you can select Find Now and then select that SBS user account. You'll go ahead and select OK to acknowledge both windows that kind of come up here. OK first to select that SBS user account, and then OK again to make sure that we're actually selecting that user for the process. Then we're going to enter the local credential passwords and select Apply and OK. And that's where it can be really helpful to have that keyboard out there. Next, you're going to restart the service, and that's just as simple as right-clicking it and then clicking Start on that. And then we're going to repeat this for Illumina Local Run Manager Job Service and the Illumina Universal Copy Service. And then after completing this for all three of those services, again, the iSeq 100 should be able to read and write to that network location, ideally. If you do run into any unexpected situations or you're continuing to not be able to save to that output location, definitely give us a call at tech support, and we can kind of help go through some other steps that we might be able to take to help get that connected to the network for you. I did want to highlight a couple of situations that might come up on the iSeq when we're caching our credentials like this. Sometimes when power cycling the iSeq 100, which we'll touch on later on in this presentation, you might be prompted to change the password for the SBS user account or the SBS admin account. By default, the instrument requires password changes every 6 months. And so you may run into an initialization error where you see unable to connect to Universal Copy Service, and then the sequence button is grayed out when you try to launch the iSeq control software. The instrument doesn't want to start a sequencing run until it knows that it can copy that data off as needed. And with that password change, the services that we updated also need to get that memo that the password change has been made on that. I think that the password doesn't automatically default to all of these services, just as an extra added layer of security with the Windows 10, just to make sure no nefarious sources are changing passwords. And because we've changed that password, we'll know what that password is, and we can just go through those steps we just went through to update the passwords in the services section as we did in the last 2 slides. And then you should be able to initialize the iSeq 100 control software again and not have that unable to connect to Universal Copy Service message. That being said, sometimes that message can come up without a password change. Generally, if that happens, it's because there's a slight hiccup with Universal Copy software itself, and we just need to give it a fresh start manually. So I'd recommend following the steps here, starting with exiting the iSeq control software, opening up Windows Task Manager. You can get there just by hitting Control-Alt-Delete, and then going to Start Task Manager. And you'll want to confirm that UCS.exe is not running. This is another one of those instances where it might be helpful to have a computer there or a computer keyboard, so you can just type in U to automatically go down to UCS.exe. But you want to make sure it's not running. If it is, we can close it. And then we'll navigate to the C program data Illumina Universal Copy Service runs. All of the runs that the iSeq 100 has tried to transfer is in this folder if they haven't been deleted through process management. And so sometimes these can kind of get a little malformed and maybe give us some issues starting Universal Copy Service. So what we can do is just create an old runs folder and move all the files found in runs over to old runs. I like to do this just in case, for whatever reason, we do need one of those files in that location. They're all really small, so it won't cause any issues on the C drive itself, as far as like data piling up is concerned. But it is nice just to move them all over to old runs and then try to start the iSeq control software again. That should automatically launch Universal Copy Service and hopefully resolve any issues that we might have with that error message coming up. Just kind of giving it a fresh new start. And then last thing that I'll talk about networking on the iSeq 100 is just providing these resources. We have some really great bulletins about connecting the benchtop instruments and local run manager to a network location. If your IT team has any questions or if you have any questions about what I just said, this support resource has a lot of great tools on there as well. All right. So the instrument is all set up. We know where we want the data to go. Now it's time to actually go through the run startup on the instrument. So the iSeq 100 may be one of the easiest Illumina instruments to load, but it is a pretty different experience if you're used to running things like a MySeq instrument or a NextSeq instrument. So I wanted to highlight some of those key differences so we can plan for them. To start, washes are not necessary. So all the fluidics are contained in the discarded reagent cartridge, and so that means no washes are required prior to running. Next, before loading the cartridge, a double-stranded library and the flow cell are loaded into the cartridge. Then clustering occurs on board after the instrument denatures that double-stranded library through another onboard process. So on that iSeq 100, you don't need to do that denaturation step. It's going to do it for you. Next, sequencing on the iSeq instrument uses a CMOS chip instead of a camera and one-channel chemistry. This is unique to the iSeq and allows the optics system to be incorporated into the consumables. I've added a link here to a tech note that describes the chemistry and the CMOS chip in more detail on this slide. I wish I had time in this presentation to go over that one-channel chemistry because it's really, really fun to see how it exactly works out. I do recommend checking that out, that tech note, if you get a chance to today. And then finally, the last part to prep for is that analysis piece, which can be completed on board when using Local Run Manager or LRM. You can set up LRM to do that generating for FASTQs if you'd like. One part of that I mentioned here is the reagent cartridge itself. With the reagent cartridges being cartridge-based, it's really important to thaw reagents using the specified guidelines here. Because that cartridge is encased in plastic and we have all of the fluidics around it, and then the bag itself has some air, it does take a long time to thaw these reagents. Much longer than our other reagent cartridges where you're just putting the reagent cartridge itself in a water bath. There's a lot more insulation there. And so it's difficult to tell whether the reagents are thawed. But by following these protocols, you'll not have any issues. You'll make sure that everything is thawed on there. So the first one I want to mention is the quickest method, which is the water bath. You'll just put it in that water bath at 25 C for at least 6 hours, but not more than 18 hours, or performance can be impacted. And then another note on that is that if you received your cartridges that day, we don't recommend going directly from the dry ice that the cartridges are stored in into a water bath, as we have seen that there can be some issues with the onboard mechanics of that cartridge if you do that. And so would recommend, following the room temperature or following the 4-degree thawing in the refrigerator rather than using the water bath technique. The next one that I want to talk about here is the room temperature. This one, thawing in air, just thaw for at least 9 hours, no more than 18 hours. I think this one's really helpful, especially because, you can leave that cartridge out and then pick it up the next morning. You can, set it on a lab bench before you leave for the day, pick it up the next morning and start that run. And last, for the most amount of flexibility, you can thaw that in a 4-degree refrigerator there. For the iSeq V1 reagents, those are stable for up to 72 hours prior to using. And for the iSeq V2 reagents, those are stable for up to 7 days in that refrigerator there. So a lot of flexibility with those iSeq V2 reagents. So if you know that you want to do sequencing next week, you can put it in the refrigerator over the weekend and then kind of get that started by Wednesday or Thursday, which is kind of nice. And then finally, the last thing I'll say is, we don't recommend refreezing the reagents once they are thawed, as that could cause issues with the run as well. We just haven't tested that refreezing event, and so would recommend, once you've started that thawing, to continue on with thawing that reagent cartridge. And then finally, we have a great support bulletin that goes over thawing and storing reagents in general on the instruments for optimal performance, which touches on some of the information here on the iSeq 100 as well. It's also really important to make sure that we're thawing the cartridge within the bag that it's shipped in, especially if we're thawing in the water bath. Occasionally, we have seen holes in these bags that can cause the reagents to take on water. Prior to thawing, I recommend checking that reagent bag, and if you see a hole, I would recommend thawing at room temperature or in the refrigerator. That way, no water leaks into the bag itself. If the hole is discovered after the reagents are thawed in the water bath and the bag took on water, I would recommend not using that cartridge and reaching out to us in tech support for any warranted replacements. We have a really nice picture of, what a hole in the bag might look like on there. Another thing to note is that if you do need to get that run started soon and need to thaw in a water bath, but you notice that hole in the cartridge, we have had some customers have success with placing that cartridge in another sealed bag and thawing in a water bath. You'll just want to check that that second bag is properly sealed. And I did also want to highlight the V2 reagent cartridges again. In the last slide, we talked about, that they are more robust in the refrigerator, can store up to 7 days. We've also rounded the cartridges in the V2 version of those reagents to try to help minimize the number of holes that might appear on these iSeq reagent cartridges. And to that point, also just want to do a quick plug for the V2 reagent cartridges. A lot of labs are on the V2 reagent cartridges as the V1s have been obsolesced. If you don't have that notification, you might be able to search it in your email with that PON 2020-1071. Just as a note, those iSeq 100 V2 reagent cartridges have been available since September 9th of 2020. And technically the last ship date for those iSeq V1s were March 31st of 2021. So you're not able to order those any longer, but you might still have a couple, kicking around in the lab that you could use. But I would recommend, when able, moving to these V2 reagent cartridges. We have some information and links on the right side there. But just some highlights there is the improved formulation and recipe, those rounded cartridge corners, increased stability. We also have some updated recommendations on loading concentrations, which you can find in the Denature Dilution Guide if you're using those V2 reagents on that instrument. All right. And then now that we've thawed our reagent cartridge and we're prepared for that, after we load that reagent cartridge and flow cell, the last step is going through the pre-run check. It has two components, an instrument check and a flow check. And on the instrument check side of things, if there are any unexpected situations or errors that come up, those instrument checks can be retried. But if the pre-run check stops during the flow checks, those reagents can't be run again, and that test can't be repeated as that cartridge has been pierced at that point. And so highly recommend, if that situation comes up, highly recommend giving us a call. As a note, it takes about 15 minutes to complete, and the run does automatically start after a successful completion. What I would recommend, is getting a cup of coffee or doing a lap and then coming back just to make sure that the system checks or those pre-run checks all pass. And if any unexpected situations do occur, we can take a look at those errors and kind of take a look at those logs in the iSeq 100 pre-run checks report section, which is detailed out here. You'll probably have the tech support rep asking for those files that are stored in that location there. And then, after going through that pre-run check, your run starts sequencing. The longest run on the iSeq 100 is a 2x151, which is about 19 hours of sequencing time with, per our specs sheet, about 1.2 gigabytes of data generated. And then after sequencing completes, we're on to run review. So let's take a look at two different applications for run review. We'll take a look at first, clustering has failed messages and how to kind of get over those hurdles. And then also, optimizing the loading concentration with % occupied and % passing filter. So this message, the software does not detect any clusters and has ended the run, contact Illumina Technical Support and discard the consumables, comes generally about 5.5 hours after the run starts, 5 hours after the cluster generation, and then 22 minutes for the 10 cycles of chemistry that it does. And it will state that, again, that the software does not detect any clusters and the run has ended. There are a few ways to confirm that clustering failed on that iSeq 100. The first is by reviewing the data. You can either take a look at it in Base-Based Sequence Hub or Sequencing Analysis Viewer. Generally, what you'll see is a low intensity, generally, under 100. And then at cycle 6, it'll just totally drop out to 0, and then the run itself will end at cycle 10. You'll see just a total flat line, as you can see in this image here. You can also review thumbnail images. On the top here, you can see a good run. You can clearly see a lot of clusters on there across the flow cell. And then you can also see one where run ended early. You can kind of see that artificial autofocusing of the JPEG causing that black and white striping as the instrument tries to make sense of that blank flow cell. So that's one way to kind of confirm that clustering did in fact fail on the instrument. Finally, a real surefire way to know that a run may have experienced a clustering error is when the Illumina Technical Support team reaches out with an email because your instrument is utilizing Illumina Proactive, and in tech support we got a notification saying that the run ended early with that cluster is not detected message. And so we'll reach out to the primary contact on the iSeq 100 and ask them a few questions about the run just to make sure that we're troubleshooting that as needed there, to make sure that the instrument is up and running appropriately. So that clustering has failed error message has a couple of different root causes for those types of errors. Clustering incorporates a lot of different aspects. It incorporates the reagents itself, the instrument, or the library. So, if an Illumina rep reaches out by email, you'll probably see a lot of these same suggestions on the screen here. First, we'll want to confirm that the instrument is running okay by performing a system check. Bringing it all the way back to the beginning of the presentation, those system checks, again, are very useful and very robust. If needed on the library side of things, it's always a good idea to double check the QC and re-quantify the library being run. Kind of a sub-step to this is checking the run setup side of things as well, including that denature and dilution calculation, confirming that the thawing protocols were followed, and confirming double-stranded DNA was loaded. And finally, if the system checks pass and the library quality is good, we recommend rerunning that library, and then if successful, reaching out to us if we haven't contacted you already for any warranted replacements. Even if you do get these messages, I'd recommend reaching out to Illumina the first time it happens, just to kind of get that case started and help ensure that it gets resolved as quickly as possible as well. We're always happy to help, kind of talk out different situations on the instrument to kind of see, why this might have occurred, and hopefully we can kind of, pretty quickly resolve that. So now let's talk about runs that do go to completion. How to tell if a run actually performed well. In general, we have our Illumina iSeq 100 specifications page that can help us determine if a run was actually successful. But what about optimizing runs to ensure that we are getting the most from every run? So what we can do are using the percent occupancy and the percent passing filter to actually optimize library loading. The iSeq 100 flow cell uses a pattern flow cell, that was first introduced on the iSeq X instrument all those years ago now. So it's using that pattern flow cell, so the instrument knows where each potential cluster on the flow cell is located. And with that information, we can optimize the library by looking at the percent of wells that are actually occupied versus the percent of wells that are passing filter. That information can help us determine why that run might have a low passing filter, for example. So low passing filter can be caused by underloading or overloading. The underloading side of things, you'll have your percent passing filter always lower than your percent occupied. And that's because those unoccupied wells are blank and they're not going to pass filter. The instrument is not going to make a bunch of G base calls because those wells are empty. It's just not going to count them any longer. So sometimes if you have if you do have a low percent occupied from underloading, you will get a low percent passing filter. So that's one way. Another way that we might see it is overloading. If the percent occupied is too high, sometimes that high occupancy can result in poor quality base calls, which leads to low percent passing filter. I'll say, on the pattern flow cells, it's a little bit more difficult to overload those runs, but it can be done, and sometimes we can see low percent passing filter if that occurs. So, now that we have an idea of the different ways that percent passing filter can manifest, let's actually go over an example of determining underloading versus overloading. So this information can be generated in Sequencing Analysis Viewer, or SAV. What you'll want to do first is navigate to the Imaging tab and then select the Scatter Plot tool. I have it in red at the bottom there. Until we got this percent occupancy starting on the NovaSeq instrument, I had never actually used this scatter plot, but it's actually pretty cool for looking at some other metrics, but we're focusing here on the percent occupied and percent passing filter values. This example here is actually using a NovaSeq, so there's a lot of data points that you'll see here. On the iSeq 100, it's really similar, just we're using, obviously less data points than on a full NovaSeq flow cell. But the idea is still the same. So then once that plot comes up, you'll select the percent occupied. I like having the percent occupied on the x-axis and the percent passing filter on the y-axis. And then you'll kind of evaluate that curve, evaluate the shape of the plot. In an underloaded example is kind of when that percent passing filter almost perfectly matches the percent occupied, maybe a couple of percentage points lower. That would indicate to me that the instrument is, really accurately able to count the clusters that it does see. In an overloaded situation, you might kind of have this straight line effect, where the percent occupied, is at, let's say like 98%, and then we see a range going from, in this example, 66% to 76%. That might be an overloaded run where we could reduce the loading concentration a little bit and hopefully get closer to this, Goldilocks situation on the far right side here with the optimally loaded library. It looks kind of more like a cluster of dots rather than a straight line up and down or kind of a slope. Where the percent occupied and the percent passing filter match, that optimal loading concentration there will kind of look like that cluster. We also have some really great resources here on the bottom left and right side. The right one is a video, and the left one is a support bulletin that was written by our technical support team that goes over exactly kind of what I showed here, exactly how to make this graph so you can evaluate different runs so that hopefully you can get the most out of your sequencing data each time. And then last but not least, I wanted to kind of put all of this together in one sort of slide, if it's helpful to have this in your lab, just to kind of see all those pieces put together on one slide. All right, so now that we've gone over some steps on how to evaluate a run, finally, let's take a look at post-run management. We'll be talking about a few of the things that happen after a run completes. So to start, we'll be looking at clearing out your disk space. As we talked about, runs are saved locally, and then the way to delete those are through process management. Again, we're clicking on that left little hamburger menu on the top left side, and we're going down to process management over here, and then it will look like the screen on the bottom right here, a little screenshot there of different runs. You do need at least 2 gigabytes of data free to start the next run on an iSeq 100, and we don't recommend using that local hard drive as a permanent storage location. Would recommend, putting that in a different location, whether that's a network, base-based sequence hub, or, even an external hard drive in some instances. So once you're able to, I would recommend cleaning this out when a copy of that data has been safely saved in a permanent storage solution. I had mentioned earlier, universal copy service error messages that you might receive. I actually had one case fairly recently where universal copy service was kind of getting hung up because there were so many runs that it was trying to account for, essentially, because there were, over 30 runs on here, and universal copy service had to quickly check, have I sent this over? Have I sent this over? So it's nice just to kind of clear this out so we don't run into any situations, even if it's not the hard drive filling up. Some of the other softwares might run into some unexpected situations. So I would recommend, clearing out this process management, maybe, every month or every 2 months, because again, there's not too much data that gets generated, but it is nice to make sure that this is cleared out so you don't run into any unexpected situations during actual run setup on the iSeq 100. And then other maintenance that's required is actually changing the air filter on the iSeq 100. We do recommend changing that air filter every 6 months. If your iSeq is under an active service contract, I would recommend reaching out to us in technical support to have additional air filters shipped out to you. I believe an extra 1 is sent when that instrument is first sent out. that first-time run setup poster will definitely have that information, but I believe that one extra air filter is sent out. If your instrument's on contract, reach out to us and we'll send out those air filters. If you're not on contract, you can purchase those air filters here through that part number. And then actually going through with replacing that air filter is a pretty painless process. Luckily, you don't have to be an engineer to go through with it. Essentially, you're just pressing the right side of the top panel. You'll go ahead and remove that panel, and then there's a little foam air filter essentially there. You'll go ahead and remove that and then place in the new air filter into the panel. Then you'll insert the 2 panel hooks into the holes there and then press that panel back into place. And then you'll be good to continue sequencing on that instrument. Another great post-run management technique is power cycling the instrument. You'll hear us in technical support say power cycling a lot. And it's basically just a fancy way to talk about shutting down the computer and turning it back on again. The big difference here is that we're actually turning off the rear toggle switch to ensure that the instrument's hardware components go back to home as well. So the Windows computer shutdown allows for the software to reset, and then the toggle switch allows for the hardware on the instrument to reset and kind of go to its home. We'd need this if you ever experience any initialization failures. If you experience system checks failing or pre-run checks failing and you're not able to resolve it just by retrying, I would recommend a power cycle in those situations. You know, if you're just getting general errors in the control software, a power cycle can really help. And then we have some guidance on actually performing that power cycle here. You know, first again, we're starting with that hamburger menu on the top left. And then all the way at the bottom there, we have the shutdown system option. You'll then go ahead and click the toggle switch on the back, I believe that's the right side of the instrument where the plug actually comes in. Right above that is a little toggle switch. And then you'll leave it off for about 30 seconds. Then you'll toggle the rear toggle switch back on. And then you can press the power button on the left side of the instrument. And then you'll have, you know, fully power cycled the instrument, and then it should, at that point, start booting back up. So then what happens when a power cycle doesn't exactly resolve those potential unexpected situations? We'll move on to restoring to factory default. These next 2 sections are technically, you know, a type of post-run management, but they're also some really powerful troubleshooting tools that we have to support the instrument and, you know, make sure that we're able to overcome any unexpected situations. So we'll start with restoring to factory defaults, which essentially brings the software on the instrument back to a factory fresh state. So the iSeq 100 can be restored to that factory default, and the process will wipe and restore the C drive. The D drive, where the data is actually stored, is going to be left untouched. You might need this if you forget the Windows password. The password gets reset to the standardized one. Sometimes, you know, if the IT team pushes something to the iSeq instrument that might be causing some errors, this will help reset all of those settings. And if you get some instrument is failing to initialize error, these factory resets can help restore the original settings that the instrument was able to pass with initially and hopefully be able to resolve this in the future. I do have some great tips and tricks for helping make sure this factory restore is a little quick and a little painless. First, I would recommend keeping installers for the iSeq control software and any relevant local run manager modules on the D drive. It makes installation simple and quick. When you do that factory restore, oftentimes the internet gets disconnected because the instrument is no longer either on that network and you need the IT team to help resolve some of those situations. So I would highly recommend, you know, keeping a version of the iSeq control software, preferably, you know, the latest version on the D drive for use, as well as, you know, like the generate FASTQ module. It's also important to confirm that no important run data is stored on the C drive with the lab that you're in. Generally, no run data should be stored there, but, you know, some runs can sneak over there just because of the small size of an iSeq 100 run. And then also making sure that you have the test flow cell and cartridge ready, because you will have to do first-time setup again once you do this factory default, restoring to the factory default, sorry. All right, and so then let's kind of go over what restoring to factory default entails. So after restarting the Windows computer, you've probably actually seen this screen where it says, choose an operating system. Generally, this will kind of automatically go on to booting into the iSeq 100, but if you select Restore to Factory Default Settings, it will go through an automatic reboot and then start restoring those factory resets. It takes about 30 minutes to complete and generally will go ahead and go through several reboots. So you can just kind of walk away from the instrument, expect it to kind of be turning on, turning off, turning back on. And then once restored, the system will have the original factory settings, except the control software will be uninstalled. You'll need to go in and log into the SBS admin and SBS user to reset the passwords as prompted. You can reach out to the tech support team for the default password. It's also in the user guide as well under that first time setup on page 11 of the user guide. And then you can install the iSeq control software. We recommend installing the iSeq control software and local run manager modules in the SBS admin account. This is also a great time to go through any network setups depending on how you're going through troubleshooting with the tech support team. It might be useful to go through that at this time as well. And then finally, bringing it back to the beginning of the presentation, you'll go through that first time setup. And so generally, this will help resolve a lot of errors we might be experiencing on the iSeq 100. But what if after all that, the instrument still isn't up and running? The last tool in our toolbox is the Advanced Exchange program. That Advanced Exchange is available in most regions. Other regions can continue to rely on field service engineers. But if that instrument is not performing to specification, reach out to Illumina Technical Support and we'll start troubleshooting that process and start the Advanced Exchange process if needed. As a note, the instrument does have to be under a service contract to be eligible for that exchange. And just a little bit more context on what that Advanced Exchange actually is, the lab and technical support team will help confirm that the iSeq 100 is experiencing an instrument issue. And then if we're deeming that instrument as unusable, a new instrument is actually mailed out to you. And then you'll help us return that non-working instrument in the box that the new iSeq 100 came in with the included return shipping label. And this is really just to make sure that the lab is up and running as quickly as possible after a downed instrument. So we'll send that instrument out before getting it back to us, and then you can just send that over back to us in that box. There's also some really great information on page 52 of that iSeq 100 system guide. Should knock on tables. None of us have to go through this, but if you do, we do have some information on that page 52 there. All right, and then last but not least, I want to touch on some resources that we have available for the iSeq 100 instrument. We have a really great set of resources on our support page. The first, just some general information in our documentation section, as well as the software download section. There's some information there on local run manager downloads, as well as those iSeq control software installers that we discussed. We have some great tech and application notes. I want to highlight the clustering optimization overview guide, as well as that sequencing library QC with the iSeq 100 system. There's a really great use case there for sequencing on the iSeq 100 to help manage pools before they're run on the NovaSeq instrument. We also have some great video resources. Earlier this month, maybe last month now, I did the iSeq 100 introduction webinar. We have a great video resource if you have other questions just about the iSeq 100 in general. In that one, I did have time to go over the CMOS chip, and so if you have questions about one-channel chemistry after checking out that tech note, there is a section in there that goes over it. We also have some great info on optimizing the cluster density, best practices, and diagnosing suboptimal clustering on pattern flow cells. We have a lot of great resource bulletins as well. Highly recommend checking out some of these. Just quickly looking through here, I highly recommend the How Much by X spike-in is recommended when sequencing low diversity libraries on Illumina platform. Always really helpful to get an idea when sequencing libraries outside of a whole genome library. And the other one that I would recommend is how many cycles are in my SBS chemistry kit. That can really help get a better idea of what type of sequencing you can do on the instrument. All of them are really great, but just highlighting those two. All right, perfect. Well, thank you all so much for your time. I really, really appreciate you hanging out with us this afternoon again. I hope this session has been helpful for you all. If you have any questions, we have some information here. You can also reach us at Illumina Technical Support. Thank you again. Really, really appreciate it. And at this time, I will pause for some water. And Janice, do we have any questions in the Q&A?